Let us evaluate the integral 1 by e to the power x plus e to the power minus x dx. You see that you have something on denominator and something on numerator. Generally in this kind of situation, what we do is we get something on denominator such that its derivative is numerator. Do we have such thing here? We have e to the power x, derivative of e to the power x is e to the power x, but we don't have e to the power x in the numerator. So why don't we multiply numerator by e to the power x? But once we multiply numerator by e to the power x, the integrand are not equal. So what we do is we multiply the denominator as well by e to the power x. Now they are equal. Let us simplify the numerator as well as denominator. 1 into e to the power x is e to the power x. E to the power x into e to the power x is e to the power x, whole thing square. E to the power minus x into e to the power x is just 1. Dx as it is. Now as we said earlier, we have some term in denominator such that derivative of denominator of that term is equal to numerator. Do we have? Yes. So let e to the power x equal to t. Then dt dx equal to derivative e to the power x is again e to the power x. Therefore dt equal to e to the power x dx. So this integral can be written as e to the power x dx can simply be written as dt. And then we have e to the power x is equal to t, so t square plus 1. Now integral of 1 by t square plus 1 dt is tan inverse of t. But we don't have anything like t in the equation. In the equation we are having e to the power x, but we are taking t equal to e to the power x, so we replace t by e to the power x, and of course we have some constant of integration. So this integral is equal to tan inverse of e to the power x plus some constant, and we are done.